In the last section, we laid out a couple of different rules around Dart's type system. In this section, we're going to talk just a little bit more about types. In particular, we're going to look at some of the very basic types that are available to us in Dart. All right, here we go. So on the left-hand side, I've listed out a couple of very basic types, and then on the right-hand side, we've got some example values of each one. You and I have already taken a look at the string type. A string type is a series of characters that get put together into one value. So an example of a string type would be, hi, how's it going, and that's great. One of the other very basic types that we're going to be making use of in many of our programs is the int type as well, which is short for integer. An integer is any number, negative, 0, or positive, that does not have a decimal associated with it. So an example of an int would be 0, negative 999, or 876,000. One of the last very common types that we're going to work with quite a bit is the double type. This is a number that has a decimal associated with it. So the big difference between integer and double is the presence of some decimal. Examples of doubles would be 0.001, negative 999.814, and you get the idea. Now, besides these very basic types, we also have this dynamic type, which we briefly discussed in the last section. The dynamic type down here is still technically a type in Dart. The dynamic type means to say we have a variable that can hold any value that we wish. So if we had a variable with a type of dynamic associated with it, that variable could reference any type of value, like the string right here of hi, the double negative 0.0004, or the integer 90. Now, the last thing I want to mention very briefly about types before we move on to our next topic is have a quick discussion about why we care about types at all. This is probably one of the more important things to talk about, especially if you're coming from a dynamic language like, say, JavaScript. So let's very briefly talk about some of the benefits of using a type system. One of the most marked benefits is that whenever we use a type system, there is the possibility of improving the performance of our application. Even when you use JavaScript, which is a dynamic language, when that JavaScript code gets executed, the interpreter that's executing that code is technically still doing some type checking behind the scenes. And so anytime we use a dynamic language, there is a performance penalty associated with it. By using a type system, we have the possibility of getting some improved performance. Next up, it tends to be a little bit easier to work on large projects when they use a strong type system. So if we're working on some very large project where we have to make use of some code written by another engineer, it will be a lot easier if we could get a better idea of what the structure of data is that comes back from some code of theirs whenever we execute it. So if we're working on a large project with many engineers or even just a few, it tends to be a little bit easier to work with a language that has strong typing. Next, there tends to be slightly less of a need to write unit tests around any language that has strong typing associated with it. For example, if we're making use of Ruby or JavaScript, we might want to run a test that says that anytime we run some particular function, we always get back an array or a string or an integer. So if we're using JavaScript or Ruby, we definitely would want to write a test like that to make sure that, in fact, yes, we get back an array or a string or whatever it is. But when we're making use of a strongly typed language with Dart, we get a little bit more assurance that whenever we say that some function is going to return some specific value, chances are, yep, in fact, it's going to return that type of value. Finally, it makes life a little bit easier for finding very simple errors. For example, if we go back over to our Dartpad project over here, let's say that right before we try to print up the string right here, we tried to retrieve the length of this string that we returned from the myname function. So if I wanted to get the length of some particular string, I could write out name.length, like so. Now when I write this code out right here, Dart has the ability to look at the type of variable that the type of value that this variable is referencing. Dart knows that it is of type string. Dart can then go check to see if string has a length property associated with it. And in this case, yes, it does. If we instead returned an integer from the myname function down here instead, like say int, and then returned the number 123, Now we're getting a nasty error message from this line of code because Dart is able to know that name is now storing an integer, and an integer does not have a length property associated with it. So again, by using a type system, we get a little bit better ability to find very simple errors like that inside of our code. Now really quickly back over here, I am going to undo those changes I made. Very good. Okay, so in this section, we spoke about some of the very basic types that are available to us inside of Dart, and we also spoke about why we care about using type systems at all. So let's continue in the next section, and we're going to take a look at the very last line of code inside of our program, the print statement. So quick break, and I'll see you in just a minute.